Hi, welcome to the third question. We are going to examine the solution to the third question. And as usual, the solution to this problem can be found in UTS Online. However, I would encourage all students to try this on your own. The first thing I'll do is I'll start a new tab. And on this new tab or in this new worksheet, we are going to solve three simple equations. So the first equation that we're trying to solve would be 3 equals x plus x to the power of 4. In this question, we are going to use the solver tool in order to solve for values of x that satisfies this equation right here. And before we use the solver tool, it's always a good idea to create a simple plot so we can see where the roots approximately lie. So what I'm going to do is I'll create a simple table. In my first column, I'll create a range of x values, and on the next column, this would be f of x. And in this column, I'll have the range starting with -5, and I'll increase this by 0.5. So 0.5 is our interval size. I'll drag the bottom right corner in order to use the autofill feature to fill the numbers in for us. We do not need to manually type it in. We can let Excel figure this out for us. And f of x will simply be, well, before we move on, we should probably rewrite this equation into the f of x form. So in order to do that, I'll subtract both sides of the equation with 3. So that would leave us with x plus x to the power of 4 minus 3 equals 0. And just rearranging the terms slightly, we have f of x equals x to the power of 4 plus x minus 3. We can use this equation to obtain the values along the vertical axis. So right, let's do this. This will be x to the power of 4 plus x minus 3. And I'll copy and paste this to the cells below. And once we've done that, we can select every number, all these numbers, including the headers, to create our simple plot. And this plot will be used in order to locate where the roots are. So here's our plot. It's kind of difficult to see where the plots lie, as the axis scales are much too large. So what we can do is to zoom in along the vertical axis. We do this by double-clicking these values, and we can change the axis bounds here. So the minimum value would be, say, -1, and the maximum value will be 1. And once you've done that, and press enter, we can see that we have two roots. We have one root that's a positive root that's between 0 to 2, and we have a second root which is a negative root, and it's between -2 and 0. So this is very, very useful when we are using the solver tool. In the solver tool, I'll always advise all students to put in a reasonable initial guess, and that helps solver locate the results quickly. Now, I'll remove all the numbers below here, leaving these two numbers at the top, and I'll put a good initial guess. I'll say, let me put the initial guess of, let's say, 1, and I'll duplicate this same bunch of cells to this range in C4. So my first initial guess will be 1, and my second initial guess would be, say, -1.5. You can now use the solver tool in order to locate the roots of this equation. To do this, I'll click Data, click Solver, and the objective that we're trying to set will be cells D2. We want to set this to have a value of 0, and we do this by changing the variable cell C2, which is x. We can leave all the other options alone. We have no additional constraints. And once we're happy with this, we click solve, and that's our solution. We have one positive root that is at x equals 1.16. The value of f of x is a pretty small number. This number is pretty close to 0. And as you recall, whenever you see the letter E in a number, that is scientific notation. And this number is 3.02 times 10 to the power of minus 7, which is an incredibly small number. And for all practical purposes, this number is 0. Right, so I'll click OK. We'll keep the solver solution, and we would repeat the same procedure with the numbers in cells C5 and D5. I'll click the solver tool. The objective that we're trying to set is cells D5. We want to set this to have a value of 0, and we do this by changing the variable cell C5. We need to make one small change here. As our root is a negative value, you will need to uncheck this checkbox. We will need to uncheck make unconstrained variables non-negative. If you do this, a solver will work with a negative variable cells. I'll click solve, and let's have a look at our solution. We have indeed found a solution. All constraints and optimality conditions are satisfied. The value of x is minus 1.45263, and f of x is a pretty small number. So this number is can be assumed to be 0. We're happy with the solution, and there are our two roots. I'll make the cell bold. I'll make the cell bold so it's clear to the reader, the person using this Excel spreadsheet, that these two numbers are roots. And it's also a good idea to apply a fill color so it's even more clear what these numbers are. Okay, now the next thing we're going to do is to solve the next equation, which is ln x plus x squared equals 16x. Before we draw a plot, it's a good idea to rearrange this equation to be in the fx equals 0 form. And to do this, we will subtract 6x on both sides of the equation. By doing that, we'll be left with fx equals x to the power of 2 minus x plus ln x. And before we use the solver tool, we will create a plot so we can see where the roots are. Okay, so we'll have x and we have y, or f of x. And since ln x does not exist when x is less or equal to 0, I'll start with a small value of, say, 0.5. My interval size will be 0.5, and I'll just drag this to the next couples below here. You can try this with a value of x equals 0, or x equals minus 1 or minus 2. If you did that, Excel will not be able to compute a value of f of x because ln of 0 is not defined and ln of a negative number is not defined. Now back to this, I'll create my formula. So this will be x to the power of 2 minus 6x plus ln x. I'll close the format shape box to make some space on this spreadsheet. Drag this to the next below cell. And I probably need a bit more because there's no roots. We'll not be able to see a root with the range of these values. And I'll just make a few adjustments. Okay, so we can clearly see that the value of f of x is negative and the value of f of x here is positive. But it's more clear if I were to create a plot. So the plot, there will be a root. There will be a very clear point where this line is intercepting the horizontal axis. So the root will fall in between 5.5 and 6 right here. Now to use the solver tool, I would remove these numbers and I'll just put a good guess of, let's say, 5.5. To use the solver tool, I'll click the data tab, click solver. I'll set the objective to be cell J2, the value of 0, and we change the variable cells I2. Since this root is a positive root, I'll check this box back because our unconstrained variables are positive. In other words, the root that we're looking for is a positive number, so that should work. Solver has found a solution, and the solution is around 5.7. Okay, great. The last equation that we are going to solve is a fairly interesting because there are many roots. Equation x equals e to the power of minus x. In Excel, in order to express the concept of e to the power of minus x, you'll need to use the exp function. So I'll just write this here for, to make this clear. In order to draw a plot, we need to rearrange the equation slightly to get the fx equals 0 form. And to do that, subtract both sides of this equation by e to the power of minus x. So this is, we are left with sine x equals exp minus x. And now we can create our plot. I'll create a large range of x values. So I'll start with, say, -5, and I'll do this over an interval of 0.25. And f of x is sine minus exp minus x. I'll now create the plot. To do this, I'll select all the values, including the header of these two different columns. And then I'll click Insert. I'll choose the scatter plot, and I'll choose a scatter plot without smooth lines. It's very difficult to see where the roots are with this vertical scale. So what I'll do is I'll double click this vertical scale and use bounds which are smaller. So I'll use a -1 as the smaller bound and 1 as the upper bound. I'll click OK, and this tells us that we have two roots. The first root is around 0.5, and the second root is around 3. There are actually more roots in this problem. So if you were to have a large range of, and you could possibly extend this to 10 or perhaps even 20, you should see more roots. And this curve would be a sinusoidal shaped curve with multiple intersections along the horizontal axis. Okay, I'll scrub these values off and I'll just leave this in. And I'll duplicate these 4 cells to a space below those cells. I'll use a guess of, let's say, 0.5 and 3.0. And I can now use the solver tool. The steps are very similar to what we've done previously. I'll click solver. The objective that we wish to set is cells P2 we want to set this to a value of 0 by changing variable cells O2. I'll check this because we're dealing with a positive root. Okay, so there's a problem with the formula. This is informing me that I'm missing an equal sign. So I should, let me just do it again. I'll objective to cell P2. Now, if it doesn't work, you can actually click this button and choose cell P2. And I'll try this with the variable cells O2. Okay, now that should work. Okay, so that did work. I did not need to have an equal sign in the formula. If I were to click this to return to solver's parameters dialog and click OK, you would see that there's no equal signs. So perhaps I made a typo somewhere in the formulas. Anyway, I'll click solve. I'll keep the solver solution and I'll check this. The first root is 0.58. The second root can be found by clicking solver again. I'll set the objective to be cells P5 and I'll set this to a value of 0 and redo this by changing variable cells O5. I'll check this because our root is a positive root. I'll click solve and solve has found a solution and this is our solution. So I'll make this cell bold, I'll make this cell bold, and I'll highlight this cell so it's clear to us that these two numbers are the solution this exercise. All right, that's it for this exercise, and I look forward to seeing you in the next video. Thanks.